Imagine buying a house, paying the mortgage every month, raising your family inside it, and believing the foundation beneath you will last for generations. Then, one day, you notice a crack. At first, it looks harmless. Then another appears. The cracks spread across the basement walls, branching into strange patterns. Concrete begins to crumble. What once looked like a perfectly solid foundation slowly starts coming apart from the inside. And the terrifying part? The house may have been doomed before you even bought it. Across Connecticut and parts of Massachusetts, thousands of homes have been caught in exactly this nightmare. The damage has been linked to a naturally occurring mineral called pyrrhotite, which was unknowingly incorporated into concrete used in residential foundations. Connecticut estimates that as many as 35,000 homes could potentially be affected. And in the worst cases, repairing the damage doesn't mean patching a few cracks. It means lifting the entire house off the ground and replacing its foundation. But how could something as ordinary as concrete become a ticking time bomb? To understand that, we have to go back decades, before homeowners knew there was anything wrong. The past. In the early 1980s, construction was booming across northeastern Connecticut. New homes were going up, and concrete was being poured into foundations that were expected to last for generations. One company at the center of the story was J.J. Mott's Concrete Company, based in Stafford Springs. The company used crushed rock aggregate from a nearby quarry in Willington, Connecticut. That rock came from a geological formation containing significant amounts of pyrrhotite, a naturally occurring iron sulfide mineral. At the time, there was no obvious reason for a homeowner to be suspicious. The concrete looked normal. The foundations were poured. The houses were completed. Families moved in. And life went on. That was the problem. The damage wasn't designed to happen overnight. Pyrrhotite can remain hidden inside concrete for years. When the mineral is exposed to oxygen and moisture, however, it begins to oxidize. The resulting chemical reactions produce compounds that occupy more space than the original material. That expansion creates pressure from inside the concrete. Tiny cracks begin to form. Water and oxygen penetrate deeper. More pyrrhotite is exposed. The reaction continues, and the damage accelerates. What begins as a microscopic chemical reaction can eventually become a foundation covered in cracks and weakened concrete. And this is what made the crisis so difficult to detect. A family could move into a brand new house and see nothing unusual. 5 years could pass. 10 years. 15. Sometimes even longer. The house might look completely fine from the outside, while a chemical process was slowly eating away at the concrete beneath it. In some documented cases, the warning signs didn't become obvious until many years after construction. The Connecticut crisis ultimately involved homes built with concrete from J.J. Mott's between 1983 and 2015, meaning some affected houses were already decades old before homeowners understood what they were dealing with. And then, around the 2010s, something began to change. Homeowners started seeing cracks that didn't behave like ordinary settling. Basement walls developed what engineers describe as map cracking, a web-like pattern spreading across the concrete. Some foundations showed discoloration and other signs of deterioration. At first, there were plenty of possible explanations. Concrete cracks. Houses settle. Temperature changes. Moisture causes problems. So why was this happening to so many homes in the same region? That question would eventually lead investigators to something hiding inside the concrete. A mineral that had been sitting there for years, waiting for air and water to begin the reaction. And once scientists discovered what was happening, the scale of the problem became much harder to ignore. When the cracks couldn't be ignored. By the middle of the 2010s, the problem was becoming impossible to dismiss as ordinary settling. Homeowners were reporting foundations covered in expanding cracks, sometimes forming patterns that looked almost like a spiderweb across the concrete. And then investigators started asking a much bigger question. Why were so many homes in the same region developing the same kind of damage? In 2015, Connecticut launched an investigation into the deteriorating foundations. The evidence began pointing towards something inside the concrete itself. The culprit wasn't the cement. It was the rock mixed into it. Investigators found that aggregate from Becker's Quarry in Willington contained significant amounts of pyrrhotite, and that aggregate had been used by J.J. Mott's Concrete Company in residential concrete. The state concluded that pyrrhotite was a substantial contributing factor in the foundation failures. That discovery changed the problem completely. This wasn't simply a few defective houses. The same source of aggregate had supplied concrete for homes across the region. And now homeowners faced a terrifying question. How do you know if your house is one of them? Finding the damage. You couldn't simply look at the foundation and know for certain. Some cracking can happen naturally as buildings age. So investigators developed ways to separate ordinary concrete problems from the much more serious deterioration associated with pyrrhotite. One option was a professional visual inspection. Another was far more invasive. A core sample could be drilled directly from the foundation and sent for laboratory analysis to determine whether pyrrhotite was present and how much was there. Connecticut eventually created programs to help eligible homeowners pay for these tests. But finding the mineral wasn't necessarily the end of the uncertainty. Because the real question wasn't simply, is pyrrhotite in this foundation? It was, how far has the damage progressed? And can the foundation still be saved? For homeowners who received a serious diagnosis, the answer could be devastating. The house had to be lifted. Once a foundation has deteriorated severely from pyrrhotite, patching the cracks isn't enough. The problem is happening throughout the concrete. According to the Massachusetts Geological Survey, the effective remediation for a severely affected foundation is to lift the house and completely replace the concrete foundation. Think about what that means. The roof stays. The walls stay. The furniture may still be inside, but the entire structure has to be carefully supported while the foundation beneath it is removed. Then a completely new foundation has to be constructed underneath the house. It's an extraordinary engineering operation and an extraordinary bill. Estimates cited by the Massachusetts Geological Survey put the cost of foundation replacement at roughly $100,000 to $250,000, depending on the circumstances. And that created a second crisis. The concrete was destroying the foundation, but the cost of fixing it could threaten the homeowner's finances. When a house stops being an asset. For most people, a home is their largest investment. But what happens when potential buyers hear that the foundation may be deteriorating? The house can become extremely difficult to sell or finance. And insurance created another complication. Because pyrrhotite deterioration can develop slowly over many years rather than from one sudden event, standard homeowners insurance often did not cover the damage. So families could find themselves trapped. They still had a mortgage. They still had property taxes. They still had ordinary household expenses. But underneath the house was a foundation that could eventually require a six-figure replacement. And the longer homeowners waited, the more complicated the problem could become. A crisis becomes a government problem. By this point, Connecticut could no longer treat the situation as a collection of individual homeowner complaints. It had become a regional infrastructure and housing crisis. The state began creating programs to help homeowners test their foundations, assess damaged properties, and find ways to finance repairs. Connecticut also established the Connecticut Foundation Solutions Indemnity Corporation, a captive insurance program designed to provide financial assistance for eligible homeowners dealing with pyrrhotite-related foundation damage. The state later created additional loan assistance for homeowners whose repair costs extended beyond the assistance available through the program. The response also changed how defective foundations were treated in the housing market. Connecticut required additional disclosures concerning concrete foundations, while municipalities were given mechanisms to reassess properties affected by defective concrete. And the state took action against the companies connected to the problematic aggregate. In 2016, Connecticut reached an agreement restricting Becker's Quarry aggregate and J.J. Mott's concrete containing pyrrhotite-bearing aggregate from being used in residential foundations while the investigation continued. Importantly, the state noted at the time that the agreement itself did not constitute a finding of legal wrongdoing by the companies. Connecticut officials noted in 2016 that there were no state or national standards specifically limiting pyrrhotite in foundation aggregate. The crisis changed that. Massachusetts worked with its Department of Transportation to reduce the risk of corrosive sulfide minerals entering concrete. while geological researchers studied affected quarries and how pyrrhotite causes long-term deterioration. If you live in northeastern Connecticut or western Massachusetts, particularly in a home built between 1983 and 2015, your foundation could potentially be affected. Start with a professional inspection. If suspicious cracking or deterioration is found, an engineer can recommend core sampling and laboratory testing for pyrrhotite. In Connecticut, eligible homeowners can seek assistance through the Connecticut Foundation Solutions Indemnity Company, or CFSIC, which was established to help with testing and foundation replacement. Massachusetts has no equivalent CFSIC program, but state geological resources can help homeowners investigate whether their property lies in an affected area. The important thing is don't wait for severe cracking before investigating, because when the problem is inside the foundation, waiting can turn a hidden defect into a massive repair bill. If this video opened your eyes to a crisis hiding beneath thousands of homes, like and subscribe. We uncover the hidden problems affecting people's homes, money, and lives, often long before anyone knows to look for them.